Right? A rational number is a number that could be written as a fraction. A rational fraction is a function that could be written as a fraction of functions. So you have, and they use the letters for numerator and denominator. Numerator function divided by a denominator function. That's what I mean by a rational function. And specifically, the denominator function's got to be a function of x. Right? You can't have a constant function in the denominator and really call it a rational function. You okay with that? So the graphs of rational functions, for the most part, there is no common function for a rational function. There's one kind of rational function that we did use last year, and I'll show here in a minute. But for the most part, there's not like one kind of graph, and then we can just move it around by adding numbers and putting in minus signs and stretching and shrinking and all that kind of stuff. These are characterized by asymptotes, right? Asymptotes are generally horizontal and vertical, although we'll see next class that actually they don't have to be horizontal and vertical. There's one other kind of asymptote, which you've not seen before, but you'll see it next class. Okay. So there's the two kinds of asymptotes that we're going to deal with today are vertical asymptotes, which are lines that have the equation is x equals a number. And these lines you usually dash in on the graph, and the function cannot touch those lines no matter what. A vertical asymptote is absolutely a place where the graph doesn't go. That's not what a horizontal asymptote is. A horizontal asymptote is a horizontal line, which means y equals, that the graph approaches when x becomes large. Meaning as you go to the extreme of the graph on the right, which is infinity, or the extreme of the graph on the left, which is negative infinity, it should be that the function is trending to that line. It's getting closer and closer and closer without touching.